Okay, so this is a demo of the Glazing app, and I suppose the first place to start is just why we need this. And I guess in this model, yes, good enough to show it. We've got two types of curtain walls. We've got a curtain wall with kind of a standard grid system, and then inside of each grid cell there's a system family. And the system family is just made up of one material. So if we look at that system panel, it's glazed. The one on top is solid. So we've got a solid panel. If we edit the type, we can add a analytical construction from the constructions XML file, and yeah, we can select whatever kind of glazing we feel like there that kind of fits. And that's all kind of straightforward. FenestraPro for Revit reads that, uses the U values that we get from it, and end of story. So yeah, that's kind of the base use cases covered in that sense. But what we have with other clients is curtain wall panel families that are more complex, that are not just one material making up a cell. So if we look at this curtain wall, I've modeled it kind of on a floor-by-floor basis. So this is kind of the ground floor curtain wall, and then they stack on top of each other. And yeah, I did that for just for ease of getting the families right. Doesn't need to be that way, but that's how I've done it. But if we look at this, let's unpin this and just turn it into a glazed panel. So if we look at this curtain wall, the grid is 4 meters high, or a cell within this curtain wall grid is 4 meters high, and I think from memory 2.4 meters wide. And so let's undo all that. So we've got, within this curtain wall cell, we've got one panel type, which is curtain wall panel 01. But you can see that within this curtain wall panel there's 1, 2, 3, 4, at least 4 kind of elements that we can see. There's 2 glaze elements, there's two solid panels, and then let's open up the family. Let's save that. If we look at that family, so this is the outside view. But yeah, you can see we've also got an internal sill element, which there's a visibility parameter attached to that, so we can switch them on and off, or we can switch the visibility of this geometry on and off. Behind the it's an aluminium. Yeah, there we go. The material is a solid panel, but the material itself is anodized aluminium and blue. So behind that panel we've got a bit of insulation, something to represent a bit of insulation. Somewhere I've got a material, so that's your fiberglass batting, and that in itself is it's a generic model family. So we've got kind of families within families. So this is this concept of having nested families inside of one curtain wall panel family. And so yeah, I think since Revit 2019 we have the opportunity, or the API allows us to look inside the curtain wall panel family and see and go through the families making up, the nested families making up that curtain wall panel, and we can get materials, we get the geometry for each nested family, and we get a material reference to that geometry. Unfortunately, that's about all, so it does mean we need to make a couple of assumptions. So that kind of drives a bit of the way that the Glazing app works, which is maybe not as intuitive as one would like, but yeah, like I say, all we get is a geometry and a material reference for that geometry. So let's go back to the model and let's start up the app. So we start up with I think it selects the first window it finds, well, it's the first curtain wall panel, but there we go. It's easy enough to navigate from Revit, so all you need to do is just select the panel. and that's selected. Okay, we've got the Revit ID reference, we've got a orientation reference. You can see that that's south, so that's correct. At least shows that I've modeled the curtain wall panel correctly, that I'm getting the right orientation from it. If you look up here, you see, okay, so I can start from the beginning. This is similar to FenestraPro for Revit. We've got a dashboard, which is kind of an information panel, and that's up at the top. And below that, we've got kind of our work area. So this is where we work on the different materials and geometry that we found in the panel. And then there's a bit of a context area here. So depending on what's happening on the left-hand side, the context view changes here. So nothing's happening at the moment. We haven't started anything, so we get a bit of information about how to get started, and the endpoint that we're trying to work through to export a CSV file and to write to a database that FenestraPro for Revit can read. So anyway, back to the dashboard. You can see that there's nothing happening at this stage. We don't have a U factor, and we're assuming that everything is framed because nothing has been, none of the materials have been categorized, and well, we read some numbers from what we can get from the Revit materials, so we use those to populate at the start. But yeah, like this 754 number is a bit of a nonsense. I guess it's something to do with the material, so we'll override that, and we have the opportunity to do that. But while values are empty here, and while the values are not categorized, we kind of just show 0 for the U factor for that panel, just to kind of force the user to categorizing and to get the user to assign a category for each material and a performance value for each material. And yeah, like I say, none won't cut it, so you need to go from none to one of these other categories. Now, if there's geometry that you don't know what to do with, you can exclude it, and in that case we will still get a U factor, and we can work through the app. So that's the option: assign it or else exclude it. So let's start at the top. So that's our anodized silver aluminium material. So I've modeled these families. I know what the frame material is. What you could also do, maybe in the case of users where they need to work on their own families, to get the, it could be that they make a material called frame, or they make a material called solid panel, something like that, so that they can identify later. But anyway, like I say, I know that my frame, all the frame materials have been modeled in this anodized silver aluminium, so frame, and I know that that's not great. So I think we've got bouncing 0.62. Let's put in something like 7. Okay, and then we've got the anodized blue aluminium, so those are these solid panels. So find the solid units category, and let's assign that same value, 7. It's our value. Okay, glass clear glazing, so that's obvious enough. That's a glazed unit. Okay, and this is where link comes in. We can select a value from link. So let's assign a triple glazed unit for fun. Okay, so that's been assigned, and you can also see, oh no, sorry, you won't see it yet. You can see that we've got for this glazing, we've got a solar heat gain, we've got a visual light transmittance. And this impacts up in the dashboard later on. I'll come back to that. So the fiberglass batting, I know, is a solid unit. It sits behind this aluminium panel. And so fine, let's assume, let's take that R value. So once I'm happy enough with that every material is categorized, categorized meaning anything from these values, just can't be none, and that there's a performance value for all the materials that are included, I can refresh the zones. By zones I mean the performance zone. So we're using the NFRC calculation method, and so for that, yeah, we're using a weighted average for all the different exposed performance zones, we're calling it in our app. They don't really give it a name as such. So let's move that out the way. So yeah, so our viewer has been populated. And we've gone through the app now, but based on the categories we've assigned to different geometries. We've worked out what the exposed faces are. So by exposed face, I mean kind of the elevational, the faces that are exposed that are in the same plane as the curtain wall, so that we get elevational areas of these different performance zones that are exposed to the outside, if you want to put it that way. I can highlight those, so we see it in the app. So it's highlighted in the Revit view, it's also highlighted in the app. So there we've got our first aluminium panel, the second panel, and then we've got two more exposed faces, so that big section of glass, we see it there, we see it there, and this big, so the neighboring section of glass. So basically there's 4 performance zones that we've picked up for this family instance. And so yeah, like I say, we've tried to design the app so that it gives an answer more often than not. I'll show you what I mean, but at this stage we've already got a U factor for this panel. We've got a percentage frame, we've got a U factor, we've got solar heat gain coefficients and VLTC based on the weighted average of the glazed areas. So you can see that that there is only one glass type, and the glazed area is 100%. So that's the weighted average. So I can at this stage override those if I like them or not. If you have some other information that you could use, so we'll override those two. The exposed area we get from the curtain wall cell area, so that's correct for this type of family. If there are families where the panels are not parallel to the center line of the curtain wall, then yeah, we need to approach that a bit differently. There's a bit of a different workflow for that, and I'll cover that in another video with a different model as well. And in that case, you're going to need to override the exposed area. But for this type of curtain wall family, or this type of modeling, we don't have to worry about that. We're okay. So to get back to these exposed faces, so we've got our first aluminium solid panel. So if we look at that, this exposed face is made up of 2 layers of material. It's made up of the anodized aluminium, and then behind that we've got a fiberglass batting. So if we go back to the family, you can see we've got the family, and then we've got the solid panel, the aluminium solid panel, and then behind that we've got also an extrusion. Actually it's a model just representing the insulation. So let's go back. Okay, so if we look at this at the NFRC calculation guide again, you can see how they're working things out. So we need to get a U factor for the center of panel, and then a U factor for the edge of frame, the edge of the panel bordering onto a frame, and then in cases where there's a divider, so something that's touching the surface of the outside surface but not breaking the surface, in that case we call it a divider, and in that case we're looking at a center pane U value, and then or U factor, and then a divider edge of panel U factor. So to try and we obviously need the user to populate that if they have that information to hand. So that in that case they're using things like Therm or software like Therm to get the values that they'd need there. But basically we would then select that performance zone, okay, or that material within that performance zone. So let's start with the aluminium, and so you can see what it looks like. You can see its relationship to the neighbors. And again, I've modeled this family, so I know that the center pane value is there. I know what the relationships are going to be. So you can see that we get these edge of frame. Let's get to the same one. These edge of frame areas. Okay, and so I know that's my that this for this panel its butting or its neighbor is the frame, and the frame does break the zone, so I'm using that value. So yeah, like I say, we use a value of 5.678, which is an imperial is 1. So no, I can't remember if this is an imperial model or not. Let's see. Yeah, this is a metric model. So if this was an imperial model, the U factor would be 1. What have I done now? I've got to close it. So this, yeah, that means that basically we can, as soon as we've assigned a U factor or a U factor to a panel, or an R value to a panel, we get a result, and then we can fine tune it by going through these zones and getting the sides. So let's get to side 1. So the frame, and what was the center pane? The center was 0.1, so it's got to be worse, doesn't it? Say 2. Let's copy that. Okay, and I know that all around is the frame, so I can drop that in. Frame. If I'm happy enough with that, I'll save it. Okay, so that's done for this family type. So yeah, I don't need to go to every single instance. I don't need to go along this row and do it for each one. I've done it once for that type, and that's sorted out now. And then I would do the same for the batting. So just for time, I'm not going to do that, but yeah, it's the same idea. So I know everything is frame. So let's leave that alone. Again, the same idea for the neighboring performance zone. I'd have to go through the aluminium solid panel and the fiberglass batting behind. And then we get to the glazing. So that's one large glazed section. Let's clear glazing. And again, same as the solid panel, I know that there's frames to each side of it, so I can assign all of that. So I'm not going to do that for this. So let's assume that we're all okay here. I do want to look at the neighboring panel, because that's slightly different. So yeah, if we go back to the model, sorry, the family, it's got just to show it, I guess we've got a generic model family that we've inserted to represent a sill, for example. There's it's attached to a visibility parameter, so I can switch it on and off per instance, per family instance. So for this instance of these curtain wall panels, the sill is visible. Now you can see we've gone back to 0 here, so that means that something is missing. And you can see that we've got 2 new materials we've found, and two new geometry elements we found as well. So we've got a birch, which is the top of the sill, and I'm going to exclude that. I think it's such a small area we don't need to worry about that too much. But the gypsum wall is kind of that area there. And so let's give that a solid unit, and let's take the R value. And if I refresh the zones, you'll see that we're now picking up that sill element in the viewer. And if we go down to the glazing, so the glazing, okay, so yeah, for the viewer it's a bit tricky. In the Revit app, in the Revit view, we see it a bit better. So for the glazing, we can see that there's one big exposed face, which is the glazing itself, but then we see that behind the glazing there's also an area made up of the gypsum wall geometry. So that's the sill, and let's go through that. So basically, if I start looking at the different exposed zones there, we'll start with the glazing. And okay, yeah, again, in future versions we'll have to look at the view here. It's a bit complicated, just the way that we've done this, to actually extrapolate that point back in Revit, but to actually get the correct extent of this performance zone. The glazing is actually, well, let's do it the other way around. So this is the sill, sitting behind the glazing. So, but in terms of performance areas, that would be one performance area, and the white glazed area you can see above is the second performance area. So when I click glazing here, I'm actually looking at this area, if you can see on the mouse. So like I say, in future versions we'll look at that to try and just increase or just get the right, you can see we didn't get it in the Rev view either, to really get the right geometry or the right highlighting so that people know what's going on. So that's the one thing that's maybe not that intuitive. But so if we look at the glazing, we're looking at side 1, which is the top, side 2, which is shown here but is actually on the top of the sill. Now the calcs will have the right areas, so even though we're showing something that's maybe a bit not as accurate as it could be, we are getting the right areas from the calcs. Side 3 is the side, side 4 is the sides. Okay, so we've got a center U factor, that's fine, 1.5. So side 1 is the top, I know that's frame, and so let's just 1.8. Copy that. Side 2 is the bottom, so again, like I say, it's showing the bottom there, but we're actually looking at the top of the sill. So and that means that my neighboring performance zone, if you want to call it that, is the sill itself. So that's gypsum wallboard. The sill doesn't break through the overall zone, so it does not do that. So we're calling it a divider. So if we look at the NFRC, we're looking at a condition like this D, and yeah, so we're looking at a DE U factor. So that's 1.7. Okay, on the sides I know that that's frame, so we're back to that's frame. Okay. And so at that stage we've dealt with the two family instance, or the two instance types that we've got for that curtain wall. And so I'm happy enough with that, and I'm ready to export that curtain wall. So basically all you need to do is select the curtain wall, and you'll see the view changes slightly, and it just asks you to populate it. We do that because if we populated everything automatically, what we had, obviously some of our clients have very, very big models, and so if it populates automatically, you're looking at a couple minutes while the user is unable to use their model or do too much. So we've gone kind of an opt-in approach, so you need to populate the curtain wall. You need to explicitly populate it. So I've worked through the panel types, so I'm happy enough that I'll get the right results here, and I'll populate that curtain wall. So yeah, this is a small one, it went fast. We get an R value for the frame. I don't actually think there is anything exposed, but yeah, we'll put something in anyway. And on the right hand side here we see that we've got one populated curtain wall. So as you move through your model, you would work through the different panel types, panel instances, family types, whatever, and as you populate curtain walls, you'd add them to the list here. You can also, let's see, where are we, 247. Oh, sorry. So if I go back to there, instead of populating, so yeah, I haven't worked on this curtain wall panel at all yet, so I can't. Well, I could populate it, I guess, but it isn't populated yet. But the storefronts, this curtain wall has been populated, so all I can show it. I can also delete the curtain wall if I don't need it anymore, or for whatever reason made a mistake or whatever it is. But anyway, at this stage I'm ready to export, so let's export that. And there's my export. So yeah, we get the Windows overview, curtain wall overview, and then we get, for the selected curtain wall, we get the, where did it go? We get that curtain wall. So we get curtain wall 279, 247, and all the panels inside. And along with this export, we also write the U values for those panels. Sorry, we write the U values for all of these panels into a database which FenestraPro for Revit also reads. So when FenestraPro for Revit starts up, it goes through the curtain wall, it checks the panel ID against the database, and if any saved values are found there, then we take the saved values instead of anything that might come from Revit. Because, like I say, this is the problem we have with nested panel types, is that we can't really take this analytical construction. It doesn't mean anything when you've got nested panel types or complicated. Yeah, that's the descriptions here just don't cut it. So in that case, then we take the saved U values and solar heat gain coefficients and VLT values for the panel. So that makes FenestraPro for Revit then a lot more accurate. Okay, thanks very much.